Lesson 3. Basic Concepts of Physics, Study of Robot Chassis and Construction. Contents. The topics covered in this lesson are: Basic Concepts of Physics required for robots. Structural design concepts. Design trade-offs. The tasks or activities for this lesson include: assembly and construction of VEXT EDR robot chassis. Force. The push or pull of an object is called force. A force is a vector quantity, having both magnitude and direction. The SI unit of a force is Newton. Force control plays an important role in the design and control of robots. Gravity. Gravity is a natural force by which all objects are attracted to one another. On Earth, gravity provides weight to physical objects. Gravity is dependent on mass, and the Earth's mass is much more than the objects in it. The gravitational pull of the Earth on objects is much more than the gravitational force between the objects, as the masses of the objects are negligible compared to the mass of the Earth. Hence the gravitational force of attraction between other objects is negligible. Laws of motion. The 3 laws of motion were compiled by Sir Isaac Newton. It describes the relationship between the body and the forces acting on it and the motion of the body in response to those forces. The first law of motion states that every object in a state of rest or uniform motion tends to remain in that state unless an external force is applied to it. Note: the following experiments are performed in space. In the left picture, you can observe that the ball from rest changes to motion when air is blown at it. In the right picture, you can observe that once the ball is in motion, it continues to be in motion, unless stopped by an external force. Laws of motion. Newton's second law states that the sum of the forces on an object is equal to the mass of that object multiplied by the acceleration of the object. Here 3 balls are used: a copper ball, a rubber ball, and a plastic ball. Since the mass of the copper ball is more than the mass of the other 2 balls, for the same application of force, the copper ball moves slower than other lighter balls. Hence large force is needed to move the heavier objects. Laws of motion. The third law of motion states that for every action, there is an equal and opposite reaction. In the left picture, considering that both are of the same mass, for the equal application of force, both react by moving in the reverse direction for equal distance. In the right image, as the cannonball is shot in the forward direction, the cannon machine recoils in the reverse direction. Forces acting on robots. A lot of force acts on a robot, and balancing these forces is important in robot control and function. A few forces that act on robots are weight, frictional force, momentum, centripetal, and centrifugal forces. Normal reaction plays an important role as robots trace paths of different types, affecting the system's stability. Weight. The weight of an object is the force of attraction that the Earth exerts on the object. As the weight of the robot increases, the slower it will move or the power consumption increases. Friction. Friction is a force that happens when 2 things rub together, like wheels and the floor. Friction opposes the motion and makes things slow down. When you push the object, friction gives resistance. The higher the frictional force, the power consumption will also be more. Activity 1. Is it an advantage to have friction or not? Why is it advantageous? Why is it not advantageous? Activity 1. List down where friction could be an advantage. Activity 1 Solution. Advantages depend on the situation. Here, friction helps in the braking system of the vehicle. In a ball bearing, the friction should be 0 to perform its action of rotation. Friction between tires and the road helps in the motion of the vehicle. Momentum. Momentum is a measure of inertia in motion. Alternatively, it is also the rate of change of force that an object experiences while in motion. The momentum is transferred from one object to another object. Centripetal force. Centripetal force is the force that acts on a body moving in a circular path and is directed toward the center around which the body is moving. In these pictures, tension, gravity, and tension are always acting towards their center. Centrifugal force. The apparent force that is felt by an object moving in a curved path acting away from the center of rotation. In the washing machine, water is extracted from the out of the clothes due to the effect of centrifugal force. Center of gravity. The center of gravity is the average location of the weight of an object. The center of gravity is at the head of the hammer due to the heavier mass at the head of the hammer. It is easier to balance the hammer with the palm, more surface contact, than with the tip of the finger. Activity 2. Balance robot by placing mass at different positions. As the center of gravity shifts outside the frame of balance, the robot becomes unstable. Stability. It is the state of being firm and secure. Here, the robot is not stable, due to an imbalance of the center of gravity. Stability. Here, the thrust generated by propellers is equal to the gravitational force, hence the glass is balanced on the drone. Stability. Here, the robodog is self-stabilizing, although the person kicks at the robodog causing it to destabilize. Eventually, it stabilizes itself without falling to the ground. Stability and center of gravity. The lower the center of gravity, cg, the more stable it will be. In an F1 car, most of the mass is lower to the ground and hence has lower cg and is more stable, while the truck has mass above the ground and hence higher cg and low stability. Stability and center of gravity. The lower the center of gravity is, the more stable it will be. As the center of gravity of car A is higher, it topples while turning, while car B has a lower center of gravity, it doesn't topple. Stability and center of gravity. The larger the area of the base of support, the more stable it will be. A wide base of support makes this robot stable. Stability in car. Rigid bodies with a wide base and low center of gravity are more stable and less likely to tip over. An example is a high-speed racing car. Activity 3. In which case the bus topples over. And why? Activity 3 solution. The closer the center of gravity is to the center of the base of support, the more stable it is. As bus B is inclined more, the center of gravity is away from the base and hence it is less stable. Mobile robots. These robots can move from one point to another without being fixed to one position. Wheeled mobile robots have applications ranging from home robots such as Roomba for cleaning floors to space exploration robots such as Mars rover. Legged mobile robots mimic living organisms in structures. A humanoid robot such as Sophia can walk and talk like humans. Other robots like hexapods and octopods are inspired by insects. Wheeled mobile robots. The dynamics, kinematics and locomotion play a vital role in the design of wheeled mobile robots. For locomotion, use different wheel types such as omni wheels, mecanum wheels, or unicycle wheels based on the requirement and application. Dynamics is the study of motion in which these forces are modeled. Kinematics is the study of the mathematics of motion without considering the forces that affect motion. Wheeled mobile robots. The most common robots can instantly move forward and backward but cannot move to the right or left without the wheels slipping. Parallel parking requires a series of maneuvers. To allow sideways sliding, use of rollers around the rim of the wheel, such as the omni wheel and the mecanum wheel, can be used. Base of robot. This gives stability to the robot. It also houses the mechanisms needed for its locomotion. Chassis can be constructed with different structure types, geometry shapes, and various materials depending on the requirement and application. The drivetrain in the robot consists of motors, gears, and wheels. Base of robot. The base gives stability to the robot. It also houses the mechanisms needed for its locomotion. Chassis can be constructed with different structure types, geometry shapes, and various materials depending on the requirement and application. The drivetrain in the robot consists of motors, gears, and wheels. Building a chassis. The bus chassis is stable and fighter jet chassis is maneuverable and vice versa. The larger the chassis is, such as bus, the more accessible it is, and the compact it gets, the less accessible it is. An example of compact chassis is the chassis of an F1 car. Old cars' chassis are strong and rigid while modern cars' chassis are light and aerodynamic. Chassis can be expensive or affordable depending on the material being used and the fabrication techniques employed. Building a chassis. The most common robot chassis is 3-wheeled and 4-wheeled as shown. For 3-wheeled chassis, one of the wheels should be a caster wheel along with the other fixed wheels to maneuver easily. Building a chassis. Short and wide robots turn easily and have lots of control but will tend to not drive straight. Long and narrow robots will not turn easily and will have poor turning control but will tend to drive very straight. Depending on the task, one should balance the two. Chassis function. This chassis is wide, strong, and houses the battery in the base frame, making the chassis stable. It has shock absorbers to resist shocks. Summary of this lesson is, thus, we must design the chassis keeping in mind the purpose of the robot. The greater the weight of the robot, the slower it will move, or the power consumption will be more. The greater the weight, the more current it will draw. The greater the weight, the more difficult it will be to maneuver. Again, if the chassis is made light, it may break easily. If the chassis is light, the manipulator and other components will also need to be light. Task or activity. Assembly and construction of VEX EDR robot chassis. Refer to the document attached for more details. Thank you.